All right, so today we're going to be going over the intermediate value theorem. It's on page 47 of our packets. And I'm going to let you guys go ahead and, pause the video if you need to and just write this all down. So kind of copy down what we have here, and then we'll go ahead and talk about it. So one thing, this is our first theorem in calculus. And anytime we see the word theorem, it's kind of like a math rule or a math law. And so it's something that we're going to use a lot to just kind of prove different justify different mathematical expressions or equations or just kind of statements, right? So this appears a lot on the free response of the AP exam. And the intermediate value theorem, it's a super easy theorem. It's a super obvious rule, but it's just something that they're going to ask us a question of. A big thing whenever we're looking for theorems is they might say, must there be? That's a really big hint. If you see must there be, or does there have to be, or is there, something like that. That's a big hint at you that you might be using one of these theorems. Okay, so our intermediate value theorem, all theorems have conditions or setups, right? So in this case, this has two conditions. If f of x is continuous on a to b, and f of a is less than y is less than f of b. So those are our two conditions, right? First, is it continuous? Second, is f of a less than y less than f of b. So those are the two rules that have to happen. If those two things don't happen, there is no intermediate value theorem, right? You can't use it at all. So then the result of this is there has to be one value. This is kind of the location at, like the where, at x equals c, such that f of c is equal to that y value, that in-between value. So one thing I do want to point out, and I graphed this on purpose this way, is these can be flipped, right? Basically what this is saying is it's saying that y is in between the endpoints, right? F of a and f of b, those are the y value endpoints. So y has to be in between them. So, I'm going to just graph some random y. Here's our y. But what it's saying is y is in between f of a and f of b. So where is y on our graph? In this case, it's right here. And so they're saying this would be a value of c, and if you notice, c is in between a and b, right? That's what this was saying. C is in between a and b. So this is really obvious. What it kind of is like saying is, hey, if you're running, right, and maybe you're running on like a straight track, and at the end there's a door, in order for you to start here and get to the door, you have to pass through some point in the middle. That's really obvious. Now, do you have to pass through a point here? You don't have to. Could you go backwards? Sure, but you're not guaranteed to pass this point, right? You're not guaranteed to pass our second point. But you are guaranteed to pass through the first point unless you can teleport, right? And so that's where the continuous comes into play, right? One of our rules said it has to be continuous. Well, let's look at why, okay? So if you were at, the value of 1, and we wanted to get to the value of 4, right, do you have to pass through 2? Well, yeah, you do if we're going to keep it continuous. So you go in a straight line, nice and easy, you pass through 2 somewhere here. You could instead, decide, hey, I want to go down first, and then come up, and you would pass through 2 somewhere over here. You could instead even decide that you want to go crazy and go up, down, up, down, up. And now we pass through 2 a bunch of times, right? 1, 2, 3, 4, 5 times. So that's where we got into this at least one value, right? In this case, we have even more than one value. But you had to have 1. But what if it's not continuous, right? What are some examples of not continuous that we've looked at? We've looked at vertical asymptotes, right? So we could, actually this would have to go the other way. We'd have a vertical asymptote like this. And in this case, we would not pass through 2. We never got there. You could also have a hole. That's another discontinuity we've looked at. So in a hole, right? Just add that back. right? In this case, we never got to 2. And then our last one was a jump, right? You could have, a piecewise function where it jumps. And in this case, we never pass through 2. So those discontinuities, they don't, IVT, intermediate value theorem, that's what it stands for, doesn't apply. Okay? So that's kind of what we're looking at. So let's look at some graphs and investigate what this would look like. So in this case, we're going to ask, does IVT apply for f of c equals 2? Now, the first thing we're looking at is, let's look at in between -5 and 2. Did this graph ever hit 2? Well, it does right here. So we're going to say yes. And, basically what I'm going to write is there's a c somewhere. Where is that c? It's somewhere between -5 and -4, right? Now, does the IVT, intermediate value theorem, we can always abbreviate it IVT, does the IVT guarantee a value of c on that interval? Okay. Now, in this case, if we look at it, in this interval between -5 and 2, our first rule failed. Our first rule was, is it continuous? So no, IVT does not apply. If you want to be very specific, you could even add, for f of c equals 2 on, -5 to 2. Just kind of, that's good practice when you're answering questions, repeat what they're asking. Because it failed our first rule, so because f of x is not continuous on -5 to 2. Right, so it failed our first rule. It's just like our continuity, right? We had 3 rules for continuity. It has to pass all 3. Well, in order to say IVT works, we have to pass both rules. Okay, next one. Is there a value of c in between -1 and 5 where it equals 2? Well, -1 is kind of here. 5 is over here. And we're going to say, no, there's not. Right, there's nowhere that it hits 2. So does IVT guarantee? Well, it shouldn't because of no, but let's kind of just investigate and look at those rules. Okay, the first rule is it continuous? Well, in between 1 and 5, yes, actually it is continuous. But let's look at our second rule. Our second rule talked about the endpoints. So we want to explore our endpoints. What's f of -1? F of -1, if you look at this, it's down 1 over 2. The slope is down 1 over 2. So it's going up and down by a half each time. So f of -1 is -0.5. And f of 5 is -3.5, or as a fraction, -7/2. And so we're going to say basically that, I'll say something like f of c equals 2 is not between f of -1 equals -0.5 and f of 5 equals -7/2, right? So 2 is not in between -0.5 and -7/2. So just like how we wrote before, therefore, IVT does not apply. And you can just write does not apply. Again, if you really, really want to, you can add on the whole for f of c equals 2 on -1 to 5. But that part in green is, it's nice. It'll be nice to write, but it's not fully needed. You'll get full credit if you just put what I did in blue. Okay? So what are our 2 conditions? Our 2 conditions are, 1, that our graph f of x must be continuous, right? And specifically where over a to b. I'm going to put must be, I don't want is. So f of x must be, that's stronger, continuous over our interval from a to b. And secondly, f of c must be between f of a and f of b. Okay. Now, when we're talking about these brackets, I have had questions about the brackets and the parentheses, right? The continuous had a bracket, and then the value was a parentheses. Essentially, what that's saying is the bracket, it's continuous because these values must exist, right? They have to be defined. But then the parentheses is saying the y value is in between them. It's somewhere in the middle, right? So kind of in between here and here, you have to pass through this y value, right? That's essentially what mean value or intermediate value theorem is saying. So next, we're going to look at some without a graph, okay? Do these have to be continuous? Do these have to have intermediate value theorem? So our first question is, are they continuous? And before I get into are they continuous, I want to talk about how do we figure that out? Well, we want to look for points of discontinuity. And kind of our main ones that we're going to need to know in calculus are any rational equations, so anything with a denominator. Our denominator cannot be 0. The next one where we're going to have discontinuity is anytime we have a radical. Right, inside of a radical, a square root, an even one, right? An even one. This has to be even, right? The inside has to be greater than or equal to 0, right? Like the cube root of x, that's continuous, okay? So be careful. Cube root of x kind of looks like this. It's continuous everywhere. But square root of x, right? It's only greater than 0. So anytime we have an even radical, it has to be greater than or equal to 0. And then the third and the fourth cases are more fringe. They don't really happen a lot, but just be aware of them. With trig, sine and cosine are continuous. But tangent of x has discontinuities at pi over 2 and repeats of pi over 2, like 3 pi over 2. And then cosecant of x, secant of x, and cotangent of x all have discontinuities. Anytime the original was 0, then the other one would be undefined. So like where sine of x is 0, cosecant is undefined. Where cosine is 0, secant is undefined. Where tangent is 0, cotangent is undefined. Okay, and then our last one are ln's, or logarithms. So for logarithms, the inside has to be greater than 0. Now again, be careful on logarithms because sometimes you want to be careful. Sometimes they'll do ln of x with an absolute value. So now the only time it's discontinuous is if x equals 0. So that's kind of a little exception. So if you see an absolute value, then they're saying it works on both sides. So just kind of so we're aware of that graph, the graph of y equals ln of x. Right, at 1 it's 0. 1 happens at e. And then this goes to an asymptote. But if we add in y equals the ln of absolute value of x, then this graph just kind of is mirrored on the left side. So we want to be careful about that. But honestly, case 4 is not going to happen too much. The main two that you really need to worry about are denominators are very, very key. And then radicals, okay? And really denominators are a big one, okay? So in this case, we do have a denominator. So where is this discontinuous? This would be discontinuous at x equals -2, right? We set the denominator to 0. Now, is -2 in between -1 and 3? Well, actually, it's not. So what we're going to say for rule 1 is, yes, f of x is continuous for -1 to 3. Okay, you can say like on or over, because right, -2 is not. It's not in there, right? So rule 1 passed. Rule 2 now is let's check our endpoints. So f of -1, right? -4 over -1. So sorry, -4 over 1. So we get -4, and f of 3. Positive 3. I don't know why I put -3. 3 minus 3 is 0. 0 over anything is 0. So now what we want to check is this 2/3 value. Is this 2/3 value in between there? Well, no, it's not, right? So we're going to say f of c equals 2/3 is not between f of -1 equals -4 and f of 3 equals 0, right? 2/3 is not in between 0 and -4. So therefore, IVT does not apply. And kind of same thing I said with continuity, you know, it might be a good idea to underline that. Okay, next one. So same thing we're looking at. Where's our discontinuity is x cannot equal -2, right? Now is -2 in between here? It is. So now we're going to say our first rule failed. So f of x is not continuous. You can also say it's discontinuous on or over -4 to 1. And now we don't even have to do the second rule, right? If the first rule fails, we don't do IVT. So our first rule failed, and we're going to say, therefore, IVT does not apply. And again, if you want to, you know, really hammer it home, you could say, for f of c equals 2/3 on -4 to 1. You don't have to put that, but it's nice. Okay. So those were cases where it didn't apply. And up here, again, we had a case where it didn't apply. Where would it apply would be, you know, instead if, say we were looking at something like this, but we wanted to pass through -2, because now -2 is in between our endpoints. And so that's kind of, if it passes both rules, that's where it does apply. So let's try another one, and this one's a little tougher, and I'm gonna, you know, use a calculator on this one and help us out. So this one, p of x equals e to the x plus 2 times cosine of x. Now, it's tricky for the discontinuity part, and a lot of students just freak out and they stop because it looks weird. But any exponentials, anytime we have an e to the x or any number to the x, those are always continuous. Exponentials, right, are continuous graphs. They exist, you know, over all domains. The only time they wouldn't is, you know, if you had a fraction or something else, but that, you know, goes into the fraction rule. So e to the x, that is always continuous, and sine and cosine are continuous. So this one, we could say p of x is continuous on -2 to 1. And our second rule, we need to check p of -2 and p of 1. Well, I can't really plug in -2 to cosine of x without a calculator. So we're going to use Desmos to help us out. And so we're going to say e to the power of x plus 2. Oops. X plus, let's try this. E, I think you need to use a parentheses. X plus 2 times cosine of x. Okay, and then just double check whenever you're on Desmos in calculus, we're always going to be in radians. So double check that we're in radians, not degrees, you're in radians. Okay, and then we can use our table, and -2 and 1 are actually already filled out for us. So -2 occurs at -0.416. I like to always go out to 2 decimals. Okay, so sorry, 4 decimals, -4.161. Okay, in calculus, 4 decimals is going to be key. And the reason for that is they're going to grade to 3. So if you round wrong on the 4th one, they don't care. So always go out to 4 decimals on calculus. And P of 1 is at 10.8522. And notice I didn't even round that, because if I get it wrong on my 4th decimal, they don't care. But if you want to be better, you would round it. The 6 rounds the 2 up to a 3. So, but on calculus, as long as you go to 4 decimals, you're always going to get the right answer. So now, is 5 in between these values? It is. So we're going to say that P of C is equal to 5 is in between P of -2 and P of 1. And I'm going to put an arrow. Therefore, IVT applies. If you want to add on for P of C equals to 5 over -2 to 1. Okay. Now I said here, I did say if it is applying, find the value of C. And in order to find the value of C, what we're going to have to do is we're going to have to set e to the x plus 2 times cosine of x equal to 5. Okay. And this one's a little bit tougher. So we would have to write e to the x plus 2 times cosine of x would have to be equal to 5. Where does that equal 5? And you'd have to solve for it. Now, I'm not sure if Desmos does that. I don't think it does. But that should work. So now we can look at what values do they equal each other, right? And so this one you can't really do without a calculator, but what we want to be careful is our only ones that we care about are in between -2 and 1. So even though 0.334 is an answer, is that in between -2 and 1? It is. But the next one, 1.4, that's not in between -2 and 1. And after that, it crosses again at 4, crosses again at 7. Those are not. So the only one in between, right, -2 and 1 happens at -0.334. Okay, and I did say I like to go out to 4 decimals. Unfortunately, here we're gonna have to trust Desmos that they rounded correctly. But we'll say that answer is at x equals -0.334. Now, one thing to just watch out for if on the AP exam, especially the multiple choice, is they're going to actually have this written as C equals -0.334 because you're solving for a value of C. So, right, you're finding a value of C. So if you, on free response, if you just put x equals, you'll get it right. But if you remember, change it over to a C. So next one, same thing where, okay, we have a fraction. So this is going to be discontinuous at 2, but 2 is not in here. So first thing is we're going to say f of x is continuous on -1 to 1. You always kind of have to prove that you can use IVT. You can't just use it. You have to prove that you can use it. Okay, second thing is f of -1 equals -1 over -1 minus 2. -1 over 3 is 1/3. Other endpoint, f of 1. 1 over 1 minus 2. 1 over -1 is -1. And so f of c equals -half is in between these, right? -half passes through there. So is in between f of -1 equals 1/3. And f of 1 equals -1. Therefore, IVT applies. So now we're going to just solve for it. And so we're going to set x over x minus 2 equal to the c value of -1/2. Some textbooks, they'll actually even go ahead and just write c over c minus 2. Like they'll plug in c, which is smart. If you want to do that, that's great. I usually don't, but if you want to do that, honestly, it's a good habit because you are solving for a c. Okay, so we're going to go ahead and cross multiply these. You also could have multiplied both sides by 2 and by x minus 2. I'm going to just cross multiply. 2x equals, now be careful about this -1, right? It's -1 times all of x minus 2 because the negative does have to distribute. If you don't distribute, you'll get that wrong. So we get 3x equal to 2, and we get x equals to 2/3. And again, that's a perfect answer. But if you wanted to, you could have also written c equals 2/3. That would be even better. Okay. Next one, I'll leave that up for a second, or you can pause it if you need a copy. So our next one, again, this equation looks really, really hard, but it's not a hard question, okay? Actually, this is the full equation. And for continuity, we're just looking at those rules we said. Does it have a denominator? No. Does it have an even radical? No. Does it have a tangent, cosecant, secant, cotangent? No. Does it have a logarithm? No. So in this case, it's continuous, okay? So 1 f of x is continuous for 3 to 5, right? All of our exponentials, which this is, are continuous. Second rule is let's plug in f of 3, and this looks hard, but when you plug it in, it's actually not too bad. So negative half, make sure you put that negative in front or you're going to get a wrong answer. So negative half, and when we plug in negative 3 plus 3, and then minus 2. This is a little bit weird, but it's negative half to the 0, minus 2. Anything to the 0 is 1, but because the negative is outside, it's negative 1 minus 2, and we get negative 3. Okay. Then we're going to do f of 5. Negative half to the 5 plus 3 is the 8th power, minus 2. Okay. And was this 5 or negative 5? This is 5. But this was negative x. Okay, that's where I messed up. So there should have been a negative 5 here. So that's negative half to the negative 2nd power, minus 2. And remember, a negative power flips it. So a negative power flips it. So this would flip it to 2 over 1 to the squared. So 2 squared. So this is the same as having essentially negative 2 over 1 squared minus 2, and 2 squared is 4, but the negative is outside, so it's negative 4 minus 2, and that gives us negative 6. Okay, so we have negative 3 and negative 6. And we're looking for, is negative 4 in between negative 3 and negative 6? It is. So we're going to say, therefore, or we could say f of c equals negative 4 is between, you can even say negative 3 and 6, or you could say f of 3, I like to say f of 3 and f of 5, if I'm being lazy and not write out the full equal part. Therefore, IVT applies. Now that IVT did apply, now we're going to equal it. So we're going to write that full equation. Negative half to the x, negative x plus 3 minus 2 equals to negative 4. Now, if you want to cheat and use Desmos, it's okay. I'll let you. But I'm going to show this one by hand. So negative 1/2 to the negative x plus 3 equals negative 2. I want to isolate out my my negative sign. So I'm going to, my half, my exponent. So I'm going to divide both sides by the negative, or kind of get rid of the negative, right? So I have half to the negative x plus 3 equals 2. And this is where we're going to take the ln of both sides. So ln of this side and ln of this side. And even before, if we want to make it even easier on ourselves, we could flip the 2 over 1, but I'm not going to worry about that. So ln of half, ln of 2. So now what I can do with this is take this exponent and bring it to the front, right? That's our rule with ln's. So this is negative x plus 3 in parentheses times the ln of 1/2 equals the ln of 2. Now we're going to divide both sides by the ln of half. And one thing that does happen, that you will see happen, is they're going to take the ln of 1/2 and rewrite this as the negative ln of 2. That's very common. And the reason for that is this is like having ln of 1/2 to the negative 1st power. And so you can always flip these, right? Because if we brought that out, that's negative ln of 1/2, right? So that's something that you might see. I'm going to hold off on that and not worry about it, but just kind of be aware of that process. So anyways, we'll talk about that later. So we're going to isolate for x. So negative x equals ln of 2 over ln of 1/2 minus 3. And then we'll just get x equals negative ln of 2 over ln of 1/2 plus 3. And you can simplify this log a little more, but we're going to leave it like that. Okay. Now, if you had used Desmos, that's what I would want you to do on the homework. Totally fine. So for Desmos, we would just, negative half to the power of, put a parentheses here, negative x plus 3 minus 2, and then y equals, I think it was 4, or negative 4. And then just figure out where they hit. Okay, and this says that they actually hit at 4. And so, interesting enough, because of what I told you guys about that rewriting this, remember I said we could write ln of 1/2 as negative ln of 2? Well, if I do that, let's kind of look at this. That would be x equals negative ln of 2 over negative ln of 2 plus 3. Those cancel to 1. So we get x equals 1 plus 3, which is 4, which is the answer Desmos gave us. So kind of cool. That's really, really high advanced simplifying of the ln stuff. Like I said on our homework, we're not going to worry about that. Just use a calculator. So your homework should be pretty easy. Number 1 says, determine using the intermediate value theorem if the function has 0. So you're going to have to do those 2 rules. And if it doesn't apply, you say it doesn't apply. If it does apply, then you just solve x cubed plus 2x minus 1 equal to 0 if they both passed. If they don't pass, you just stop. Okay, second one, same thing, 2 rules with the 0. Okay, third rule, same thing, use the 2 rules, and if it does, solve to 0. This case, use the 2 rules. If it does, solve to 4, solve to 6, and then that's it for the homework. Okay, nice and easy, very simple homework.